Nowadays, lots of research and funding is being invested into improving the efficiency of combustion systems, such as engines or turbines, and in reducing noise. My project is further looking into this, into suggesting moving from the standard round geometry, for example at the end of a turbine, and moving towards a fractal geometry, which you can see on the right-hand side. But before I go into the further details of this, what is fractal or fractality? Fractality means repeating a pattern across every scale of a body. For example, if you imagine a tree and you look from far, you're going to see some branches. If you want to step closer, you see smaller branches attached to these ones, which has got the same shape as the main branches. If you step closer again, you see smaller branches, which again has got the same shape of the medium and larger scale branches, and so on. Fractality is very common in nature, for example in broccoli, snowflakes, rivers, trees. And in my case, I decided to take a segmentation pattern and use it at the exit of the jet to achieve the shape you can see. Now, I've done some preliminary testing to compare the round and the fractal geometry, and the difference between the two flows is massive. To start, the fractal geometry increases the amount of volume passing through a certain region of the flow at the same time. This is quite important because in this way you could promote a better mixing between air and fuel in a combustion system. And if we think that nowadays an engine or car only burns 40% of the fuel we inject into it, it's pretty promising. Moreover, regarding acoustics, there could be some improvements there too. The idea of using, for example, corners at the exit of a turbine is not new. Nowadays, if you fly, you're going to see the chevrons, which are small teeth attached to the exit of a turbine. And what they do, they reduce high-frequency noise of the turbine itself. However, the improvements are pretty modest. Calculating some mathematical correlation on my fractal jet, I found out that there could be a massive improvement into the acoustic performance for this reason. The fractal jet will allow taking the acoustic energy, which is concentrated on a very small band of frequencies, which we can hear, and will allow expanding it to a much wider range of frequencies, even outside the human-heard range, so that the noise you could perceive will be a lot lower. The end of my PhD is now looking into the 3D structure of the fractal jet, so its properties can be fully understood, predicted by computational codes, and finally implemented into industry. Thank you.